Hello, good morning everyone. My name is Aklesh Teli. I am integrated master PhD student from SL Lab under the supervision of Young Park. Today I am going to discuss about particular RF biosensor chapter 7, that is mass sensitive and thermal sensor. Now in this slide we will talk about the general introduction to the piezoelectric effect. Then we will go through the surface acoustic wave. Then also we will go deep through the thermal sensor, and at last we will conclude our presentation with different types of piezoelectric effect sensor and the thermal sensor. Now, what is piezoelectric effect sensor? Piezoelectric effect. Piezoelectric effect is such effect when we apply pressure, then it converted pressure into electrical. Means when we apply the mechanical force, then it will convert into the electrical signal. Actually, this is introduced in 1880. The Curie brother discovered the crystal those with no center of symmetry, such as a quartz and tourmaline, give out an electrical signal when mechanical stress, and then it can produce the signal. Later this is used as a sensor. Now, gas sensor application. For gas sensor application, it is useful for analyzing of vapor and the gas by the surface absorbed, and it is also lack of the sensitivity and having the very less specific coating, and for that we have also a very good hygroscopic coating such as gelatin, silica gel are used in the commercial sensor. Then organic amines will also absorb, and sulfur oxide in the reverse manner should be performed for the gas sensing. We can see in below there is the reaction when the ammonia and silicon dioxide react with the water, then it forms ammonia hydrosulfide for the reaction of the gas sensing. Now biosensor application. For biosensor application, the sensor should be more selectivity. The enzymes is present in the dry state, and organophosphorus pesticide can be detected by the use of the metal salt such as iron chloride, copper chloride, and nickel chloride by making complexes with the such compound. And antibodies are highly selectivity and highly sensitivity on the piezoelectric crystal. The quartz crystal microbalance. The quartz crystal microbalance is more practical to use a differential mode system with two balanced crystal and oscillator. In the next slide, we will see the schematic diagram of a two, two system balance of a crystal and oscillator. They are the There have been problem with the variety of balancing between the two selection, and hence a lack of sensitivity and the poor signal to the noise is absorbed. A thin layer of a metal such as a gold is plated on the surface of a crystal, which is made the working electrode in an electrochemical environment. On the left hand side, you can see the schematic of a typical quartz system, microbalance system, that is balance between the crystal and the now the quartz crystal microbalance. It is preferable to compensate for the changes in the property of the solution, such as the viscosity, which is affected by the temperature, or density. Polymer modified electrode can be used by monitoring the changes in the mass measured by EQCM. Surface acoustic wave. These are formed by using piezoelectric crystal, particularly lithium niobate, and also the wave are not generated in the bulk of the solution but on the surface. The surface wave penetrate into the crystal to the depth of about one wavelength. So the surface acoustic wave occurs on the surface. There are the number of the variation for the surface acoustic wave technique used, and some of the technique are listed below. As we can see, the plate wave mode, evanescent wave mode, lamp mode, and thickness shear mode. Now our third sensor is the thermal sensor. Thermal sensor is further classified into three, that is thermistor, and later we will discuss the two other. Now a thermistor is a very sensitive device for measuring changes in the temperature. These include boron oxide, calcium oxide, or a transition metal oxide such as copper, nickel, cobalt. Thermistor can be used to measure the small amount of heat involved in a chemical or biochemical reaction by employing a microcalorimeter. On the left hand side we can see the schematic diagram of a thermistor device. Now the second is under the thermal sensor is the catalytic gas sensor. Catalytic sensors are used particularly for detecting flammable gas. These include barium oxide, calcium oxide, or transition metal such as I previously mentioned, cobalt, nickel, magnesium. On the left hand side we can see the schematic of a catalytic gas sensor, in which platinum wire resistance is used and ceramic bed for the catalytic layer on a catalytic layer for the catalytic gas sensor. Thermal sensor, thermal conductivity device. These measure the thermal conductivity of a gas and are typically used in a gas chromatography. Heat is lost to the surrounding at the rate which is dependent on a thermal conductivity of the surrounding gas. Such devices are not used to measure chemical reaction and therefore can be safely employed in an inert environment for monitoring flammable gas residue. As in the schematic diagram of a thermal conductivity detection in the gas chromatography, we can see the gas is in and we have the filament which hit the gas. Then we have outside the heat sink where the heat is dissipated and at last the gas is out. Now conclusion. In this slide, we will discuss the piezoelectricity sensor and different types of sensor under the piezoelectricity sensor, anisotropic crystal and the piezoelectric effect, and also we discuss the potentiometry biosensor and talk about the pH link, that is ammonia link and carbon dioxide. Then we will talk about the three different type of thermal sensor, that is calorimetry, catalytic and the thermal conductivity. Thank you for your attention.